This is about Chapter 6 in your Deborah Gray Morris 5th edition Calculate with Confidence. Open the book to page 6. The metric system. A lot of what we do in healthcare and most of what we utilize is the metric system. It is a system based on increments of tens, hundreds, and thousands. We really want to stress that we use the metric measures correctly. You will learn the common equivalents in the metric system, such as grams, liters, meters, and we'll be working with that, and hopefully you will become more comfortable as we work with this chapter and the others throughout the semester. The metric system started back in the 18th century time. It was known as the System of International Units. It's a system recognized by many countries. It is the most precise system. Once we become adapted to it, it's quite simple. And it is the system of choice in healthcare in America today that governs medications and other measurements such as weights, urinary outputs, oral intakes, and so you need a good solid foundation with the metric system. The decimal system is one that the metric system exclusively uses. It does not prescribe or utilize fractions. So when our answer is written and it is in the metric system, it will be a whole number or a decimal number. It is in multiples of 10. There are 3 basic units of measure in the metric system. The gram, which is a weight, measures our solids, and as we will discuss in class, medications are measured by milligrams, and we tend to think of medications or a gram of an antibiotic or a milligram of a tablet. We tend to think of that as the strength or concentration, but it is actually the drug weight that we are administering to that patient. We use our solutions as liters. That gives us the volume in the metric system. We use increments of that liter. We use milliliters, particularly for smaller measures. For larger measures, we commonly use the liter. The meter we use less frequent, but in pediatrics you will be using the meter to measure babies' circumference of their head and chest, their length, to get accurate measurements. We also use centimeters to measure wound sizes, and we use centimeters in measuring cervix for females dilating during delivery. We work with that less frequently in math. Prefixes that memorization is absolutely necessary is your kilo, centi, milli, and micro. They have to do with the units of measures that we will look at. We can have a kilogram, and we will take the prefix and put it with the name. A kilogram. We have a milligram. We have micrograms that we use, and we use milliliters. In the past, a cubic centimeter was used as the same as a milliliter. That is no longer acceptable, and we use the milliliter only, not cc. We have a kilogram, that's our weight, and we have a conversion factor we associate with that with pounds that we will study in Chapter 9. That should have you covered on page 60. Now look on over to page 61. If you need to, you may pause this while you turn your book a little bit more to page 61 And we just talked of some of our common prefixes, and we know that kilo, common prefix, it means a measure larger than the basic unit, whereas centimeter, milli, micro mean smaller than the basic unit. We start with 67 milligrams. That is a thousandth of a gram. Gram is our unit of weight. Therefore, 67 milligrams is 67 thousandths of a gram. We would go to 67, and that would be 67 thousandths of a gram. It would be 0 point to get that answer to the thousandth position. A milliliter is a very small amount of liquid. It's 1,000th portion of a liter. A kilogram is 1,000 grams. A kilogram is much larger than a gram. It is 1,000 times a gram, where a gram is 1,000 times a milligram. The deciliter is used once in a while. We're talking about milliliters of blood, and we will reference that hemoglobins there. We get like a 12 gram of hemoglobin in 100 deciliters of blood, which is sometimes the milliliter of blood. A deciliter indicates 0.1 or 100 milliliters of blood. A deciliter would equal 0.1 deciliter or 100 mLs of blood. And that's to get the weight of that hemoglobin molecule circulating in the blood. That's just really not for you to memorize that, but to understand that a deciliter is a tenth of a liter, or 100 times a milliliter. We have a cubic millimeter, and that's length. That's used when they're counting red blood cells, and they would count them in a volume of their length times their width times their height, and get cubic millimeter, and we use that sometimes with our red cells and white cell counts that they're looking at that. Your book cautions you, and I want you to really read the cautions carefully. Do not confuse your units of measure in the metric system for weight, volume, or length. The prefixes are used for both weight, volume, and length, but the gram is weight only, the liter is volume only, and meter is length only. So we want to keep those separate. When we look at the table 6.1 at the bottom of 61, they have already done in highlight, where I would have you take your marker and highlight these. Kilo, which is 1,000 times the base. Milli, which is 1,000th part of the base of a gram or of a liter, and micro is a millionth of that, so it's a very small unit of measure. Your book also in your number 4 on page 61 gives you those examples of 1, 2, 3, 4, and 5 that you may read through. Turning your book now to page 62, there are some rules that are critical for us to follow, and we will look at these, and they are to prevent errors and ensure accurate interpretation of metric notations that are used in medication orders. These rules will apply forever until your national standards as set by JCO change them. I'm going to suggest that students copy page 63 from your book, or highlight it in your book, type you up a sheet of it, and keep it available when working your math. On those, we're going to look at those together. When you see these on box 62-2, on page 63, metric rules, we want to use Arabic numbers to express quantities. So that's using our numerical systems for quantities. we express a unit or a fraction as a decimal. If we knew we were going to give half a tablet, if we are in the metric system, we would write that as 0.5 tabs. Whereas in the household we might put 1/2 tabs. On number 3, always write the quantity, whether in whole numbers or decimals, before the abbreviation. Always write the quantity. Let's see if we got those. Yes, we've got those rules. So let me just run you back through this, and then we'll read those rules so I don't have to go quite as slow, so thank you for that. Abbreviations are first letter of the word, G for gram, M for meter, and a capital L. There's been confusion. We don't want a lowercase l, which could represent the number 1. We want a capital L for liter. So therefore, if we write milliliter, we would put a lowercase m and a capital L. When prefixes are used with the basic units, first letter of the word is written in lowercase. So milligram here is mg. Microgram is mcg. Liter is the exception, where we would have the lowercase m for milli and capital for liter. Again, there had been confusions with people mistaking that for 1 when it was written in lower case. Now with your rules, I've already told you that we express them as Arabic numbers, numerical value. We use decimals, not fractions. So if we have a fraction such as 2/5, we would divide 5 into 2 and get 0.4 grams. If you ended up with 2/5 of a gram, to change that to a decimal, and you may need to go back to the earlier chapter on decimals, you divide 5 into 2 and you come up with 0.4. Take out your calculator, do 2/5, so you would say 2 divided by 5 equals 0.4. The numerator divided by the denominator is 0.4 grams. We don't record this in the metric system. We would record this. Quantity precedes your unit of measure in the metric. When we're dealing with the metric, we put the quantity and then the unit of measure. In the household, we put the unit of measure and then the quantity, such as a cup, 2. The full spaces used, you want a full space between the number and the abbreviation so that it can be read clearly without error. This is critical. I had a student who told me she could not have made that many mistakes in her math. Stupid mistakes was the term. And after I looked over the math, she had left off this 0. She had put a 0 here. And those are not stupid mistakes. They are deadly. So we will not use a leading 0. We will use the leading 0. You will put a 0 in front of a decimal. So for instance, when we divided 5 into 2 and got 0.4, we must put the 0 in front of that 0.4. Not 0.4. But eliminate trailing zeros. So if we had an answer of 2 milligrams, we would not record it as 2.0 milligrams. What has happened across America, this has been confused as 20 because someone doesn't see the decimal point there. Because this is so critical, we're going back over it again. Use leading zeros before a decimal. So when we have a decimal, we want a leading 0. We will not record it as 0.5. You will record it as 0.4, not 0.4. You will eliminate trailing zeros. If the answer is 2 with nothing over beyond 2, you will not put 2.0. If it is 45, you do not write it as 45 point either, because this has become confused as a number 1, which would be 451, or as a 0, which would be confused as 450. So we write only that value with no decimal and no decimal zero. We write 2 milligrams, not 2 point, not 2.0. This should be clear. You may need to practice it. Go back, pause, write it down. Not that hard. Follow the decimal rule. Working the math correct while failing to follow the decimal rules, the math is still wrong. That will go for your computer test. Do not use the symbol U if you're coming from a chemical background or a mathematical background. It is not approved in healthcare. It has been confused with units. It has been confused with M for minimum, and it's not acceptable. MCG, not UG. The Joint Commission of Hospital Accreditation has a do not use list. We will look at this list. It's in your books, and it's not appropriate to have these on medication labels, prescriptions, or MARs. We used to say 5 cc's was the same as 5 milliliters. 10 cc's was the same as 10 milliliters. Because this has been confused with these symbols, with U's, with zeros, it is no longer acceptable. It is written 2 milliliters with the capital L, not 2 cc's. Joint Commission said these have been misread as double zeros, and we may still see some of these on a syringe. Somebody at the hospital that's as old or been in nursing for a long time may tell you to get them a 3 cc syringe. They want a 3 milliliter syringe. Avoid periods after units of measure, so we would write milligram, not milligram point. It could be mistaken as a 1 if written poorly. Place commas in values starting at 1,000. We would record it where we have 3 numbers and then a comma. If we had another 3 numbers, we'd have a comma. So it's 1,000 with the comma in front of the first 3 letter spaces, not 1,000 without a comma. Do not add as to make plural. That can lead to misrepresentations as 5 or other. It could come out as a microgram or be confused with legibility. So we write MG without S. These are designed to prevent medication errors. They are written because errors had occurred because of the confusion, and they are there to help keep you having a safe, happy practice in your clinical area. You have this table in your book. It is box 6-1. It has to do with your metric abbreviations, and we are very careful with metric abbreviations. We use them sometimes with math, but more and more we are beginning to write these out. You are on page 62 now. A gram is abbreviated lowercase g. A microgram is abbreviated mcg. A milligram is abbreviated mg. Kilogram is abbreviated kg. Liter, and remember we're using a capital L. Deciliter is a lowercase d, uppercase L. Milliliter, lowercase m, uppercase L. Weights. And this we're looking at on page 64. We're looking at the base of a weight is a gram. 1,000 times a gram is a kilogram. 1,000th of a gram is a milligram. Weight, and we may have already discussed in class, is the weight of the dosage. We tend to think of that as being the concentration or strength. You recognize this medication as Tylenol 500. milligrams. Here you see a 500 milligram Tylenol. Here you see a 325 milligram Tylenol. That is the weight of the medication. We sometimes think the strength of the dose. This is a Bayer aspirin. This is 325 milligrams. I put these slides here to help you see where all of this comes into place and why you're having to study the math to get a good foundation for medication administration. We have the gram as our basic unit of weight, as you see on page 64. It equals 1,000 milligrams, or a milligram is 1,000th of a gram, and 1 gram is 1,000,000 micrograms, or 1 microgram is 1,000,000th of a gram, a very minute amount. Kilogram is the only unit typically used to measure that's larger than the gram unit. We don't use those others, so for the practical purposes we won't look at those. We just know that a gram is the base, 1,000 times the gram is a kilogram. So 1 kilogram is 1,000 times larger than a gram. Here we have the 325 Bayer aspirin. Here you have the 81 milligram Bayer aspirin, and you can see it would take 325 divided by 81. Let's just do that. It would take 4 of these to equal the weight in one of these, or the same amount of milligrams. Metrics are on page 65. We're looking at volume. When we measure fluids, we look at our liter. It is the basic unit for volume. We usually look at the one that is more smaller, much smaller. The milliliters, much smaller than a liter, is 1,000th of a liter. We have 1,000 milliliters in a liter. Remember, the cc for a milliliter is no longer acceptable. In the home, most people have a pint jar or a quart jar they would use to measure. A quart, and if you'll notice this means is approximated, a quart is actually 960 milliliters, but that's only 40 milliliters, a little less than an ounce, a little bit more than an ounce. This is about an ounce and 10, 40 milliliters more than an actual liter. A pint is 500 milliliters, or half a quart. Here is your 2-liter bottle of juice or Fanta orange soda. So that's 2 liters to help you start. 2 liters would be how many milliliters? If there's 1,000 milliliters in 1 liter, how many is there in 2 liters? If you said 2,000 milliliters in 2 liters, you are correct. Here we have examples of where else you will use liters in a hospital. We give liters of IV fluid. They are 1,000 milliliters per large bag. This is a large bag. It would have 1,000 milliliters in each. So that would be 4,000 milliliters, or 4 liters laying on this table. This is the new product that companies are putting out to charge a little more and give a little less. It's a 1 liter volume of ginger ale. 1 liter has how much? How many milliliters? If you look on page 65, you see at the top 1 liter has 1,000 milliliters. If you said this drink that's 1 liter has 1,000 milliliters, you would be correct. When you look at your book on page 65, you see that in yellow it says that although pint and quart are not exact measures, they have equivalence. A quart is about the same as a liter. A quart, if somebody at home, and I was trying to say you need to drink a liter of fluids by noon each day, I would probably just say you need to give him a quart of water every day from breakfast until noon. Because to tell a family member a liter, it's not in their vocabulary, but they understand a quart jar, a mayonnaise jar, a mason jar. Those are terms that they would understand. A pint is 500 milliliters, or half a quart, or half a liter. This is a half liter. At home, this would be your pint jar. At home, a pint jar is about 2 cups, and you can see where that would be about 8 ounces here, 8 ounces there, for a total of 16 ounces. What is 16 ounces times 30? Well, that's 480. How many milliliters are in a half liter? Well, 500. 480 are very close to 500. So you would have 500 milliliters in this, where you would have 480 milliliters in 2 cups. Less than an ounce difference. Here is an example of some half-liter saline washes that we might keep to wash eyes in emergency situations. Here is a half-liter bag of IV fluid. We sometimes just put a 500 liter up if we want to be very careful and not overload a patient. Here's a can of pop, Canada Dry, ginger ale. Put this here because nursing students tend to, midway through the semester, get some type respiratory intestinal virus. You will be losing sleep, becoming very stressed, eating poor habits, hanging out of the bottom of a can of Coke and chips on the run, staying up late getting ready for test. I suggest that when you get some downtime, you put a pack of these or Sprite, whichever your favorite comfort drink is for colds and stomachs, a few cans of chicken noodle soup in the pantry, so that when you get the virus, you've got your little weapons ready to go. This is a 12-ounce can. When we take a 12-ounce can and multiply it by 30 milliliters, because there's 30 milliliters in an ounce, so we say 30 times 12, we see that there's about 360 milliliters there. When I read the can, actually, the can says there's 355. So when I do the math, 360 times 12, or 12 times 30, 12 ounces times 30 milliliters, I get 360. These are approximate conversions. They are approximate. Be sure you read the label of whatever you're giving your patient to get the precise measurement, and use graduated measuring containers to measure whatever it is that you're giving your patient. This is just a small 100 milliliter bag, a little more than 3 ounces, less than 4. So they're smaller than half a cup. This is volume for comparison. Here we have the little 30 milliliter cup that you all saw in the class the other day. Here you see a 1,000 milliliter bag. When we look at a 1,000 milliliter bag, it would be the same size as a cup. When we look at this, we could pour 8 of these into 1 cup. When we count the amount of fluid in a bag, we start at the bottom of the bag and measure as we go up to the top level of the fluid in that bag. We'll work on that with our last module this semester. Here are other ways that we measure volume. We measure volume. If we had to do a precise dose, we might use a small syringe for a child. We could pour it into a graduated medicine cup. Here you see 1 teaspoon, 2 teaspoons, and on the far side of the cup, over here, you can see it's 10 milliliters. This is the cups you've seen in the class. They are graduated. When we measure liquid medications for patients, be sure you are using a graduated measuring cup, not just a drinking cup or a Dixie cup. we've had this equivalent chart, so we want to once again look at it at the bottom of page 64. It's in your textbook. And this is where we have the equivalents to memorize. That means make a flashcard. A kilogram is 1,000 grams. 1 gram equals 1,000 milligrams. 1 milligram equals 1,000 micrograms. 1 liter equals 1,000 milliliters. 1 milliliter equals 1,000th of a liter. A meter equals 100 centimeters. A meter equals 1,000 millimeters. A millimeter is 1,000th of a meter. And if you'll notice, you need to be able to start and train your brain. You may need to make a flashcard, but if you'll start and when you pick up a can of Coke, read the label, see the 355 on it, or get a 12-ounce bottle of Coke, look at the label, look at how many milliliters, divide the number of milliliters by 30, start to see that. Start and read weights on your cereals that you buy. Start and read labels on salt that you buy. It will help you start acclimating to it with practical hands-on learning. Basic metrics conversions. Now I would go ahead and make a card with my conversions, so when I start to do my math, I've got my conversion factors. I'd have a kilogram equals 1,000 grams, a liter equals 1,000 milliliters, a gram equals 1,000 milligrams, and a milligram equals 1,000 micrograms. Put that on a card and we will continue to add through it so you have your conversion card. You convert, that means to change from one unit of measure to another, from milligram to microgram, or from gram to milligram, or milligram to gram. This is done by moving our decimal either left to divide or to the right, to the left to divide or to the right to multiply. Each metric unit in healthcare differs that we use by about 1,000 or 3 decimal places. To go from a kilogram to a gram, you can see we move this decimal place 1, 2, 3 to the right. To go from a gram to a milligram, again we moved it 3 to the right. 1, 2, 3. To go from a milligram to a microgram, we move it 1, 2, 3. From a liter to a milliliter, you would take the decimal that would be here and you move it 1, 2, 3. To go from smaller to larger, the reverse, we move it to the left. If we're going from smaller, a milliliter is smaller than a liter. Now we're going to move the decimal to the left. So we're going 3 places to the left. Are you ready? Good. We pick our decimal point up here and we'd go 1, 2, 3. Now we've learned already that if that decimal point is here, we cannot have a dangling decimal point. We must put a 0 in front. So 100 milliliters is 1/10 of a liter. To go from larger to smaller, we move it to the right. If we have 0.75 of a gram and we want to find out how many milligrams we have, we pick the decimal point up and we go 3 places to the right. So just looking at that, don't look down, but 3 places to the right. Can you tell that's going to be good? Think about it before you do it to see if you think it, so that when you get an answer, it should seem logical. 1, 2, 3. And you can see below they moved it 3 to the right. 1, 2, 3. It is 750 milligrams. You're doing great. Take a break. To do that, you have a pause button. Then you can come back. We're almost done though, so I'd hang on for a second. On page 66 is your assignments. You can see on page 66 there's your math of moving your decimal places to go from larger to smaller and smaller to larger. You have practice problems here and your answers are on page 606. If you're having confusion after you work these, please see me. You may have been bored doing this, and so you can come and share your bragging rights. You have learner activities on the Evolve under your E-Line course, and you have other learning activities under your Gray-Morris web resources, so your Evolve resources. Work through page 69 to complete these learner activities. Then I would do my computer activities. That completes this recording. Thank you.